Welcome to Storytime Science at the Exploratorium. My name is Viv, and today's episode is The Sun. We're going to be reading this book written by the Sun with the help of Stacy McAnulty, and the pictures are by Stevie Lewis. So let's get reading. About 4.6 billion years ago, a magnificent and important star was born. And that magnificent and important star was me, your sun, with a capital S. Yes, I am a star. Oh, sun has a dictionary. Star, a massive and luminous ball of gas, full of energy. And another definition for the word star is an outstandingly talented and popular performer. I fit both definitions. The Milky Way galaxy has over 100 billion stars. That makes me 1 in a billion, or 1 in 100 billion. I'm not the biggest, so what? Not the brightest, who cares? Not the oldest, whatever. But I am the most important, at least to you Earthlings. Can you hang out for 8 minutes? That's how long it takes my light to reach the Earth. Yep, I give you heat and light. You're welcome. I'm so important that Earthlings should name a special day in my honor. We could call it Sunday. Oh, wait. We already have a Sunday. I'm famous for my heat and light, but I also hold our entire solar system together. Scientists call it gravity. What can I say? The planets are attracted to me. And because I'm the center of our solar system, life revolves around me, literally. Oh, and there are all the planets: Neptune, Saturn, Jupiter, Uranus, Mars, Mercury, Venus, the Earth. Look, they all go in the same direction. And some interesting stuff on this page, too. An Earth year is 365 days. A year on Venus would be only 225 Earth days, whereas a year on Neptune would be 60,190 Earth days. That's because they're all different distances from the sun. So when they're going around the sun, it takes shorter or it takes longer than the Earth. Those other stars are far, far away from Earth, which makes them look teeny tiny and not so important. I'm close, a mere 93 million miles from Earth. To an Earthling, I look like this. But to Neptunians, I'm 2,795 million miles away, and I look like this. If there were Neptunians, there's no known life on Neptune. Technically, I'm a yellow dwarf star. Oh, look, the sun's ID card. But I'm still a big, big deal. If I were the size of a basketball, Earth would be smaller than a grain of sand. You could fit about 1 million Earths inside me. But you can't fill me with Earths because I'm hot stuff. Compare. A hot summer day, 90 degrees Fahrenheit. A pizza oven, 700 degrees Fahrenheit. The orange-yellow flames in a campfire, about 2,000 degrees Fahrenheit. Me, at my center, 27 million degrees Fahrenheit, but only about 10,000 degrees Fahrenheit on the surface. I can melt diamonds. Ancient Earthlings thought I circled the Earth. Can you imagine me revolving around Earth? And some might think that I sit in the sky all day and all night, but I got moves, baby. I'm spinning. And because I'm not solid, my middle moves faster than my top and my bottom. It takes about 25 Earth days to rotate the middle of the sun and about 36 Earth days to rotate at the top and the bottom of the sun. Don't try this at home. I'm not only important, I'm generous and good-looking. Sunrises, sunsets, northern lights, southern lights. Sit back and enjoy the show. Sometimes I like to be mysterious and sneak away for a few minutes. Solar eclipse. But don't worry, I'm just behind the moon. While I'm astronomically bigger than the moon, 400 times wider, the moon is astronomically closer to Earth, almost 600 times closer. My neighbor stars have fancy names. Meet Proxima Centauri, Alpha Centauri A, and Alpha Centauri B. Me, I just need 3 letters. Give me an S. Give me a U. Give me an N. What's that spell? Sun. Sun, sun, he's our star, light and heat from afar. Please note, that's a capital S. I am important. Not to hog the spotlight, but I've still got it. I'm the same hot, bright star I've always been. Ooh, headlines. Some stars fall apart. There might be a meltdown, a total collapse. But in the Milky Way Herald, a stable star is a good star. You don't want your sun getting hotter or cooling off. That would be really messy. So grab your shades. I plan to be in the biz for another 6 billion years. You and me, we've got a bright future together. Here we have a fact page at the end. There's a Q&A with the star of our book, Sun. Let me go ahead and read that. That's question and answer. So the question is, who is your favorite planet? And remember, this book will be read mostly by Earthlings. Of course, I don't have a favorite. Each is special and kind of puny. By mass, I make up 99.8% of the entire solar system. That's like asking a human to select a favorite fingernail. Question. You've been around nearly 4.6 billion years and are expected to shine at least another 6 billion more. How do you stay so enthusiastic? Well, I like to keep moving. As you've read, I rotate, but also about every 11 years, my poles change magnetic polarity. That means the top and the bottom of the sun. Positive becomes negative, and negative becomes positive. This causes impressive solar storms. I also orbit the Milky Way. taking Earth and all my planets with me. That's a long trip, about 230 million years. Question. From the outside, you look like a giant fiery ball. But what are you really made of? Well, mostly hydrogen and some helium. Question. When young Earth artists draw you in a picture, what color do you prefer? Technically, I'm a yellow dwarf. From space, with no atmosphere in the way, I'm basically white. But without me, Earthlings wouldn't see any colors. It would be too dark. So use any crayon. I don't mind. I would recommend adding glitter to any picture to capture my sparkling personality. Question. Last question. Do you have any advice for readers? Yes. Never stare directly at me, even during a solar eclipse, because I can damage your eyes. You delicate Earthlings can't handle my ultraviolet rays. Also, eat your vegetables. I helped grow them. It's time for our sun activity. Now, you don't ever want to look directly at the sun, just like the sun said in the Q&A and the question and answer at the end of the book. But you do want to observe the sun. So we're going to make a tool that lets you observe the sun. What we're going to make is a snowflake. It's not a snowflake made out of snow because that would melt. It's going to be a snowflake made out of paper, and maybe you made one of these before, okay? It's a fold and cut activity. We want it to be symmetrical. We want it to be radially symmetrical. That means it's like a sunburst coming from the center of the pattern. The first thing you want to do is take a sheet of paper. This is a regular 8.5 by 11 sheet of paper. You could use a smaller sheet of paper. You could probably also use a little sheet of paper like this. Anyway, I'm going to fold it in half. I'm going to try and be as neat as possible with my folding. Make a nice fold. So I fold it in half this way. Now I'm going to fold it in half this way. Okay? And now you could start cutting it there, but I'm going to put an extra fold in it. I'm going to fold it at an angle. I'm going to have that be my point. And I'm going to fold it like this, fold it over, and make a nice good crease on it. Now I'm ready to cut. The whole idea with these, and you can see in the ones that I already made, is that, well, except for kind of sort of in the middle of this one, none of the shapes that I've cut into my snowflake are round. We want all sorts of different kind of angular and squared off shapes. So I have a pair of scissors. I'm going to start in the very center, and instead of just cutting it straight across, I'm going to cut sort of a kind of a weird angly thing here. Okay, good. And now I'm going to go along this big fold here, and I'm going to slice into it with the scissors. Okay, so for example, right there, that is most definitely not a circle. Okay? And let me make another couple of them here, like diamond shapes, or even like squiggly shapes. And just in case, I also have a couple of hole punches that are not circular hole punches. I have one hole punch that's the shape of a star. I'm going to punch a couple of stars in here. Let me get it the right way around. Okay, good. So, I have to be strong. So you can see that one is a star shape. Let me do another star shape just to test my strength. I wonder if I can, I have an actual snowflake shape on this. Let me see if this will go through a bunch of different folds of the paper. Ooh. Not strong enough. Oh well, I'll do another one with the star. Now when I unfold this, it's going to be a nice symmetrical snowflake shape with lots of stars. What you want to now do is make sure that you totally flatten out that piece of paper. Now this is a tool for observing the shape of the sun without actually looking at the sun. So if you take this outside on a sunny day, you want to make sure it's not a really cloudy or foggy day. The sun has to be shining nice and bright. And you hold this really close to the ground or really close to a wall. You can see these shapes that you've cut out or punched out. But as you move this sheet of paper further and further up and away from the ground or further and further away from the wall, you'll see if these shapes still look like the nice, sharp, non-round shapes that they are. You might notice that they start to round out a little bit at the edges. And if you hold it up far enough away from the ground or far enough away from the wall, then you might notice that you have a bunch of circles. You don't have the shapes that you've actually cut in. They will all look like circles. That's because no matter what shape of hole you make, the shape of the light through each of these little holes is always going to be the shape of the source of the light, in this case, the sun. So what's pretty cool is if you don't happen to have your sheet of paper with you and you're out for a walk, you can notice if there are trees with lots of branches, and you notice the shapes between all the branches and the leaves are not circles, but you look down on the ground, sometimes it just looks like a lot of overlapping circles. The other thing that you can do is you can just do the same sort of thing with your hands. If you just crisscross your fingers over each other, you can see none of those are circular shapes. There's a square, there's a trapezoid, there's a rectangle, there's kind of almost a triangle, and you can do the same thing. You can put your hands close to the ground, again on a really sunny day, and keep lifting them higher and higher and higher. Or say you're in your kitchen, like I was in my kitchen the other day, and the sunlight is coming through a window really, really brightly, and you have your snowflake or your hands against the wall, and you can see the light coming through those shapes, and you move it slowly, slowly away from there, you'll see those shapes start to round out until they're all shapes of the sun. There's somebody who works here at the Exploratorium with me who we used to always talk about this. If the sun were shaped like a chicken, all those little shapes of light that you would see if you pulled far enough back would all be shaped like a chicken. But the sun's round. So this is a really good observation tool. And also, if you go on the Exploratorium website and you look up Bob Miller's Light Walk, he explains a whole lot about how sun images work and how things like this work. It's a really, really cool part of our website. Bob Miller was an artist who worked here for almost 20 years, and Bob Miller's Light Walk is a great place to go to learn more about the sun and images of the sun. So we've read the book and we've done the activity. I wanted a little something extra. So I looked up poems about the sun, and I found this one. It's called A Pizza the Size of the Sun, and it's by Jack Prelutsky. I'm making a pizza the size of the sun, a pizza that's sure to weigh more than a ton, a pizza too massive to pick up and toss, a pizza resplendent with oceans of sauce. I'm topping my pizza with mountains of cheese, with acres of peppers, pimentos, and peas, with mushrooms, tomatoes, and sausage galore, with every last olive they had at the store. My pizza is sure to be one of a kind. My pizza will leave other pizzas behind. My pizza will be a delectable treat that all who love pizza are welcome to eat. The oven is hot. I believe it will take a year and a half for my pizza to bake. I hardly can wait till my pizza is done. My wonderful pizza, the size of the sun.